Hello, so this is the continuation of our discussion on measures of central tendency. So we are already in example number 3. So just to recall what is example number 3. So this is the data that we are trying to solve. Wherein it's a numerical data and the task is to compute for the mean, the median, and the mode. So what will we do if we are given this data? So as we can see in our table, so it's actually in tabular form, 83.1, 85.7, 87.6, 91.1, and 95.5 appear once in the data. So it means there's no highest frequency. So if you are provided with this type of data, it means that there is no measures of, or rather there is no mode. However, what if the situation is like this? So we have 283.1, 287.6, 291.1, 295.5, and 285.7. So in this case, so 285.6, so we have twice for each of the data. It means that there is a mode, and we call it as, the term is multimodal. So if we have, for example, one highest frequency, we call that as unimodal. So one mode. Two highest frequency, we call it as bimodal. Three highest frequency, trimodal. Or in general, you can call it as multimodal. So again, in the given example, we actually do not have a mode. So how about for the median? So we can go back to our data and inspect the middle term. So the first step is to arrange our data from lowest to highest. But it seems that it's already arranged from 83.1. Next, the higher number is 85.7. Higher to this is 87.6. Higher to 87.6 is 91.1. And the highest is 95.5. So it's arranged from lowest to highest. And we have five terms here. So 5 plus 1 is 6 divided by 2 is the third term. So the third term, or by just looking at the values here, it's very obvious that the middle term is 87.6. So the median is 87.6. How about for the mean? So what will you do to compute for the mean? You will add. So let's go back to our data set. You will add 83.1 plus 85.7 plus 87.6 plus 91.1 plus 95.5, and the result will be divided to 5. So let us use our calculator to compute for that. So 83.1 plus 85.7 plus 87.6 plus 91.1 plus 95.5 is equal to 443 divided by 5 is equal to 88.6. So what is our mean? Our mean is 88.6. Now, if we are going to identify what is the most appropriate measure of central tendency, whether it is mode, median, or mean, so of course, you might answer that since the highest frequency is mean, so the most appropriate is mean. But we actually need to know the shape of the distribution because if it is normally distributed, that's the time that you can use mean. But if it is not normally distributed because it is skewed, then the appropriate is median. So we cannot yet decide whether we will use mean or median because we need to determine first the shape of the distribution. So as mentioned, if we find or we found out that it is normally distributed, then we will use mean. But if not, if it is not normal, then we are going to use median. And how will we determine if our appropriate measure, or rather if our data is normal or skewed? One way is to use histogram. But for histogram, so let us set aside our okay, so how to determine if our data is normally distributed? So let us place our answer here so that the mode is none, 87.6, and the other one is 88.6. So these are our values so that we can again come up with our table. So this is 88, oops, 88.87.6 and 88.6. Okay, so if we will use histogram, so because we have mentioned that our data appeared one, so it will actually looks like simply like this. And it's very difficult to determine because we say that it is normally distributed if this shape, for example, looks like this. This table looks like our figure of normal. So it's difficult to say that. So if this is the first one, while if we're going to sort to the second one, like comparing the mean, the median, and the mode, if our mean is approximately equal to the median and approximately equal to our mode, it means that it is normal. While if it's not, then it is skewed. So just like, for instance, if we have lowest mode, mode is the lowest, MO is mode is lowest, median, of course, is the middle, and the highest is the mean. If we have this kind of comparison or given data, our graph does not look like normal, rather it looks like this. So this is a positively, we call it as positively skewed. While if mean is the lowest value followed by the median and the highest value is the mode, we actually have a negatively skewed. data. But again, in the case of our given example that we cannot determine the mode, we cannot again state whether this is normally distributed or not. So the first method that we use is to use the histogram. Unfortunately, we cannot use it because, of course, we have only a very few data and it does not look like a bell shape. Second, when we compare the mean, the median, and the mode, we cannot, of course, do that because we do not have the value of the mode. And if we're going to consider, for example, that these values are all the mode, then there are times that it is higher, there are times that it is smaller. If we are going to claim that all of these are the value of the mode. So again, we cannot use the second method. So what is the third method? We can actually make use of the computation. We can actually use the computation of the skewness and kurtosis. And what is this skewness? Skewness is actually the symmetrical or asymmetrical shape of the distribution. So as mentioned, this is normally distributed. This is positively skewed. And this is negatively skewed. While for kurtosis, this refers to flatness or thickness of our graph. So this is our normally distributed. We call it as mesokurtic. Lower than that is called the platykurtic. While higher or peak, higher than our mesokurtic is leptokurtic. So these are the terminologies that is related actually to normality. And for us to determine, so if the shape looks like this, of course, it is normal. And if it looks like mesokurtic, it is also normally distributed. So how will we determine whether our data now is normal or not based on skewness, which is the symmetrical or asymmetrical shape of the distribution, or kurtosis, the flatness or the thickness of the graph. So we actually have several formulas to compute for skewness and kurtosis, but what we are going to consider is the computation of kurtosis in Microsoft Excel. So let us consider the kurtosis of our data. So let's go back with the given data. Okay, so what I will do is to enter now our data set. So we have the following: 83.1, 85.7, 87.6, 91.1, 95.5. The formula for skewness and kurtosis, so we can use equal skew, open parenthesis, and select enter. So this is the skewness. While for kurtosis, KURT, open parenthesis, select our data, close parenthesis. So this is the skewness and this is the kurtosis. So we actually have here table for interpretation.